Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are beginning a new topic today, trigonometry. What are the objectives that we look forward to achieving at the end of this topic? At the end of this topic, you should be able to understand and use the basic trigonometric ratios. You should be able to understand and use the Pythagoras theorem. And you should be able to solve practical problems that require the use of the trigonometric ratios and the Pythagoras theorem. So, our studies on trigonometry will be mainly centered on the trigonometric ratios and the Pythagoras theorem. We are going to begin with the trigonometric ratios. What are the trigonometric ratios? The three trig ratios are sine, which has the short form sin and is pronounced sine, cosine, which has the short form cos and is pronounced cos, and tangent, which has the short form tan and is pronounced tan. These are the three trigonometric ratios. So I said trig. Trig is the short form of trigonometry. So whenever you hear me use the word trig, I mean trigonometry. So the three trig ratios are sine, cos, and tan. To find them for any acute angle in a right-angled triangle, first identify the sides of the triangle. The sides of the triangle are 1. Hypotenuse. The hypotenuse is the longest side or the side opposite to the right angle. 2. Opposite. Opposite is the side opposite to the angle under consideration. And 3. Adjacent. Adjacent is the side next to the angle under consideration. What does this even mean? Let's find out. Let's consider this right-angled triangle. So we have this point here as point A, this point here as point B, and this point here as point C. And together they form this right-angled triangle. We know it's a right-angled triangle because we can see this sign. This sign is the right-angled sign, meaning that the angle formed here is 90 degrees. We know that a triangle that has one of its interior angles as 90 degrees is a right-angled triangle. Now you see that if this side here is 90 degrees, these two angles here, I mean the angle at angle C, the angle that will be created at point C, and the angle that will be created at point A, these two angles will be acute angles. In the video on angles, we learned that acute angles are angles that are less than 90 degrees. So these two angles will be acute angles. These two acute angles, we can find them using the trigonometric ratios. So if we know the length of the sides of this triangle, we can use the trigonometric ratios or the trig ratios to find the acute angles, the value of these angles. In the same way, if we know the value of these angles, we can use the trigonometric ratios or the trig ratios to find the length of the sides of this right-angled triangle. So these are the two main things that we will be using the trigonometric ratios to do. The trigonometric ratios that we've learned right now, which are cos, sine, and tan. We will be using them to find the value of acute angles in a right-angled triangle or the length of the sides of a right-angled triangle. Now that is what the point was telling us, that in order to find the value of the acute angles or the length of the sides of the right-angled triangle, we need to know these three sides of the right-angled triangle. The first one is the hypotenuse. In a right angle triangle, the hypotenuse is the longest side or the side opposite to the right angle. Opposite is the side opposite to the angle under consideration, and adjacent is the side next to the angle under consideration. How do we find these three trig ratios for this right angle here? Let's say that we call the length of AB, that is the distance between A and B, we call that X. The distance between B and C, we call that Y. And the distance between A and C, or from A to C, we call that H. The hypotenuse is the longest side of the right angle triangle. So clearly you can see that the longest side is AC. So that is the hypotenuse. Now we are going to call this angle here angle theta. This acute angle here, we are going to call it angle theta. In relation to the angle theta, line AC, or this time the distance H, is the hypotenuse, because moving from A to C, that is the longest side. Remember the point said the hypotenuse is the longest side or the side facing the right angle. This is the right angle, so the side facing the right angle, as we can see here, is the hypotenuse. So always in a right angle triangle, the hypotenuse is the longest side or the side facing the right angle. So in this right angle triangle, AC is the hypotenuse. Considering this angle here, angle theta, the length BC, that is from B to C, which is represented by Y, the length BC is the opposite, because BC is opposite to this angle here, which is theta. So BC is the opposite side because BC is opposite to theta. I hope you are clear. BC is the side opposite to the angle we are considering. The angle we are considering in this right angle triangle is theta, this acute angle. So BC is opposite to theta. Then the other remaining side is the adjacent. So here AB is the adjacent side. So considering this angle theta, AC is the hypotenuse, BC is the opposite side, and AB is the adjacent side. How do we use the trig ratios to find the value of this angle here, angle theta? We are going to take the trig ratios one after the other. So here we know that here is theta, this side X is our adjacent, this is opposite, and this is hypotenuse. We are going to take the first one, which is sine. So we are saying that sine of this angle here, so sine theta. Sine of theta is equal to the length of the opposite side. The opposite side is Y, divided by the length of the hypotenuse. The hypotenuse is H. So if you take a right angle triangle, sine of an acute angle in the right angle triangle is equal to the length of the opposite side over the length of the hypotenuse. So here the opposite side is Y, the hypotenuse is H. So sine of theta is equal to Y over H. With this, we can find theta. We will learn how to do that. The next one we are going to consider is the next trig ratio, which is cos. Cos of theta, or cos of an acute angle in a right angle triangle, is equal to length of the adjacent side. In this diagram, the adjacent side is X if you are considering this angle theta. So adjacent to theta is X, divided by length of the hypotenuse. The hypotenuse is H. So we have X divided by H. Then tan, which is the last one, tan of this angle, so tan theta is equal to opposite divided by adjacent. So the length of the opposite side, which is BC. BC is opposite to theta. Remember, we are considering everything in relation to theta. So BC is opposite to theta, AB is adjacent to theta. So it's opposite, which is BC or Y, divided by adjacent, which is AB or X. So tan theta from this diagram is equal to y divided by x. To help us remember all these things, we use these mnemonics. So, ka, twa. I don't know if you've heard of this before, but this mnemonic is going to help you to remember these three ratios. So is for sine. It means that sine of an angle or sine theta is equal to opposite over hypotenuse. So when you see so, it means sine is equal to opposite over hypotenuse. Ka is for cos. It means when you see cos is adjacent over hypotenuse. So A is adjacent, H is hypotenuse. So it means that cos theta is equal to adjacent over hypotenuse. The last one is twa. It means tan. So tan theta is equal to opposite, which is O, divided by adjacent, which is A. So if you remember these mnemonics, so, ka, twa, you'll be able to remember these three trig ratios. Thank you for watching this video. Don't forget to like and subscribe. In the next video, we are going to solve questions using the trig ratios that we've learned in this video. Bye-bye.